Good morning. Think everything is ready now? Is everything still okay? Do you see the desktop and you can hear me? Is everything still all right? Yes. Okay. Um, okay. So first, remember I mentioned on Tuesday that the final for this class is 2 weeks from today. So I put up a review that tells you what we've covered since the last exam. So to study for the final, you would look at the reviews from the first two exams and your two exams and the final exam. So the final exam's over the whole semester. So, go back and reconsider this review and this one, though by now these things should be pretty comfortable. You should be pretty comfortable with those. But then here's the stuff that we've done since the last exam. Okay. And over the next 2 weeks, we'll go back, as you look at, remember, there's a bunch of problems in here, like there are in the other review problems. So as the next two over the next 2 weeks, we'll look at these problems. So if people have questions about those problems, we can look at them, and I might over time add a couple more to there. Okay, so keep that in mind. You can start looking at that. The review is mostly about arrays and classes, what we've been talking about since the second exam. Okay, so that's first. Um, the other thing is, let's see. There's this homework assignment that's due a week from today. Does anybody have any question about the homework assignment? Yeah, has anybody looked at anything in there and seen anything they want to ask about in class? Any question about the homework assignment? Any questions? Okay. If you think of something, I downloaded it, so it's on the computer. It's on my desktop. So if you think of something you want to ask a question about the homework, feel free to. So then what we're going to do is we're going to keep talking about writing classes. We're going to keep talking about the idea of classes and objects. So what we're going to do is keep working on this example that we've been working with, this rectangle example. We're going to add some more features to it to describe some other ideas in object-oriented programming. Okay, so let me move the test program up to the top, make it a little bit easier to test it. Okay, so there's the test program, the test, the rectangle class that we're writing. Okay, so we're going to just add a few more features to this thing. So, okay, now let me, because it's going to start getting longer, I'm going to delete the part here. Like this was just a redundant thing, just to show you that there was more than one way to write these. So let me erase the extra stuff that was in there. So there's more room for new things. Okay. Okay. So here's if we look at, if we go ahead and visualize this. Oh, we left it with a mistake in it. Remember, okay, yeah, which is where we picked up was that where we left where we left off was that you shouldn't let somebody create a rectangle that has negative dimensions. They don't really make sense. So we're going to do this idea that when somebody asks to construct a new rectangle, we'll check that they're not giving us negative dimensions. Okay, so if the width is negative, we'll throw an error. Similarly, if the height is negative, we'll throw an error. Throwing an error lets the program tell who's ever running it that there's a problem. And that's a good idea, because if somebody accidentally puts a negative number into, say, a rectangle where a negative number doesn't belong, and then the program just ignores it, then something later on can go wrong. And then suppose at some point the program crashes. It can be very hard to figure out where the negative number in the rectangle came from. It's better to just, as soon as an error is detected, to report it immediately, because it makes it easier to figure out what went wrong. If the if the rectangle constructor immediately says, I've been giving a negative number for height, it's a lot easier to figure out who just called the constructor and figure out why they gave it a negative number. But if you just let it go and let the program keep running, eventually that negative number in the rectangle may cause a problem because it doesn't make sense. But then you may have a really hard time figuring out where did that negative number come from. So it's generally considered better to report errors as absolutely soon as possible. They shouldn't be ignored. So this stops the program, and the program will know exactly where it stopped. And the now this may not be convenient for a customer of a program, but this is mostly useful for people who are writing the program when they're testing their own programs. So this helps somebody testing their program know exactly where a mistake was. Okay. So we do this to stop a constructor from building essentially what would be a nonsensical object. Notice that then the other thing we did was if you stop the constructor from letting you put in negative numbers, what's to stop somebody from just arbitrarily putting negative numbers into the object? Now, a minute before, we had these things public. That meant that anybody could access those variables. And notice that we have our methods public, which means anybody can call those methods. Now, I fixed the compiler error, but not in a good way. Now, I can construct an object. Oh, actually, the object still has, so let me get rid of these negative numbers because that's going to crash the program. So I can construct an object. Here's the object I'm constructing. Okay, there's the object. But now I just say R4 width is -5. See, that defeated the purpose of the constructor. And now I can say the height in R4. You read this as in. You read the dot as if you want to. You can. A lot of people read it as in. Yeah, the height in R4. Set that equal to -10, and you've defeated the purpose of the constructor. Okay, so the constructor tried to stop negative numbers from getting inside the object, but now somebody can just put them in there. But we stop that by making them private. Okay, so we say that that's a private number. Okay, that's private. Now the X and the Y, I probably don't really need to make them private. I could, but I don't really need to because there's no wrong value for X and there's no wrong value for Y. So I wouldn't mind somebody going in there and saying R4X is -5 and R4Y is -10. Okay, so that doesn't really concern me because there's no wrong numbers for X and Y. So okay, so it's okay. It's okay for me, as far as I'm concerned, to reach inside that rectangle and change the X, or to reach inside that rectangle and change the Y. But I don't want somebody reaching inside for the width and height because I don't want those to be negative numbers. So I went and made those private. Okay, so you can choose what to make public and what to make private. So I'm leaving those public and I'm making those private. And certainly I should make private anything that needs to be controlled. Like if there's a part of your object where certain values don't make sense, okay, if there's a part of the object where certain values don't make sense, those parts should be private so that the constructor can control them. Okay, and if the part can be any value, there's no real reason you can make it private if you want, or you can make it public. Now there's something that we have to worry about now a little bit. What if I want to do the following? What if I want to print out what if I want to print out a message? The height is, okay, so that'll be R4 4 dot height. Well, I can't do this now because I made the height private. Okay, so now see, I want to print. I have this rectangle, and I want to print out what its height is. I can't. So I don't have a way of printing it. So that's kind of a problem. Okay. So we're going to solve this problem in two ways. Okay. We're going to solve two aspects of this. We're going to solve this problem in two ways. One way is we're going to give the method a way to ask it what its height is. Since we've made the height private, we need to give this method what's sometimes called an accessor method or a get method. We're going to write public double get height. Okay. This doesn't need any parameters because it's a method that returns a double. And what we want it to return is the value of the height field. Okay. So we'll just return height. Now notice that that's the same thing as returning this height. Now I'll leave it as this to kind of just make it clear that I'm returning the height in this object. Now remember, every object will have its own value of height. So this is returning the height of the one object that you called that method on. Okay, so now if I can now up here, I can do R4 dot get height. And it's a method, so I need to put if I forget if I just say get height, I'll get a compiler error. Okay, there is no get height. Now, without the parentheses, it acts like a variable. It acts like a field. And the fields in the object are x, y, width, and height. Get height is a method, so I have to use the method call notation, put the parentheses there. Okay, and now construct the object. Okay, poke a couple numbers into it, and now see, now I'm calling the get height method. See, there's the this. I called get height on R4, so this points to the same thing that R4 pointed at. I'm going to call the height, get the height in this object. So I'm going to get 3. So I'm going to return 3. I'm returning it to this print, and then now I can say the height is 3. Okay, so that worked pretty good. So now I can get the numbers that are the private numbers that I can get them out of the object. I made them private to protect them, but now because I made them private, I have to write this method that lets people get at them. That's why you maybe don't want to make double the x and y private, because if you make the x and y private, then you have to write more methods just to be able to examine the values in x and y. Since any value of x is okay, there's no real need to protect it, and then I don't have to write a get method for it. Now I need another get method for the width. Okay, so I need another one, public double get width. Okay, and this method is just going to return this dot width. So this word doesn't really have to be there, but I put it there right now to just remind you that it's only getting the width. It's getting the width in the particular object it's being called on. Okay, so up here the height is, and then I can write another line. The width is, then get width. Okay, so I make them private to protect them, but then I have to write methods so that you could see them, because it's pretty clear that you're going to eventually want to be able to ask what's the width and what's the height of this rectangle. Okay, so there's the get height. Now here's get width. Okay, notice that this is pointing to the object R4. I called r4.getWidth. So I called r4.getWidth, so the this becomes r4. So inside getWidth, the this replaces the r4. The this replaces the r4. Essentially, this is r4.getWidth. Okay, and then return 5. Okay, and can print out the width is 3 and the height is 5. Okay, all right. Now there's another way to solve this problem. It'd be nice to just be able to do the following. I should be able to just print the rectangle. Okay. Yeah. Yeah. You can print strings. You can print numbers. Why can't you print a rectangle? So let's see what happens if I try that. Okay. Step through the building of the rectangle. Get the height. Get the width. Okay. Now here I'm printing the rectangle. Okay. So it printed. Let's look what it printed. It printed something weird. Okay. Rectangle at 7DE. Now, what that's actually saying, okay, what this is the Java language has a default way of printing out objects. And what it does is when you print an object, it gives you the class, what kind of thing it is. Then think of it, this is essentially at, and this is the address of it in memory. So it's saying this is the rectangle that's at that location in memory. Okay. Like if I create another rectangle object, it'll have a different location in memory. So if I go up here and rectangle R5 equals new rectangle, and I'll give this just 1, 1, 1, 1. Then I could print R4 and print R5. Okay. Okay. And there'll be different objects. And the visualizer will see 2 different objects, which means that they have 2 different addresses in memory. Okay. Not that we really care about these addresses, but that's what Java's printing out for us. So let me real quickly step through this. The addresses are of no value to us. We can't use them. Okay. There's R4 and R5. R4 has an address in memory, and R5 has an address in memory. And later on, you'll learn more about what those addresses mean. By default, Java prints out those addresses. So I have a rectangle at this address and a rectangle at that address. But what I really wanted to know is what's the width, height, x, and y of the rectangle. I can get that, but I have to program it myself. This is what Java prints if you don't tell it otherwise. Let's look at how you would tell Java your way of printing the rectangle in a nice format. You do that by giving a class a toString method. Okay, so I'll put that right after the constructor because I don't want to keep scrolling up and down. So I'll put it right here. You can put it anywhere you want. You can order these methods any way you want. So what we're going to do is we're going to give a toString method to our class. Okay, now toString is going to return, it's going to be a public method that returns a string. Okay, and what it does is it's going to build a string that makes sense for what this object, it tells us what it lets us decide how this object should be printed when somebody calls print line on that object. And I think what here I'll do is I'll just do something simple. I'll just say x equal plus x. I'm going to build kind of a long string, comma, y equal plus y. It's kind of tedious to write these. It's a little bit, it's real error prone because see, I weirdly alternating between pluses and quotes and pluses and quotes. So this is part of the string, x equals, then I have to tack on the x value, then switch back to string, comma, y equals, then tack on the y value, then switch back to string, comma, width equal, now tack on the width, then switch back to string, comma, H-E-I-G-H, height equal, okay, switch back to, well, now switch to the number, okay, and that ends it, okay, so that's the end of it, so I can just put a semicolon there. That's the end of the string. So as I built this long string that I'm returning, okay, and it's kind of, these things are not easy to read. Actually, that's one of the reasons why they invented the printf. I can make this a little bit easier to read if I do it. Well, I can't, but printf is, I'm building a string, so I can't use printf. So I can't use the trick of printf to here. So I have to write this thing out kind of this long way. All right, and also, if I wanted to, I could say this X, but that just makes this thing even longer and harder to read. Yeah, it's this X, this Y, and this width. So that just, but those thises don't really have to be there. Okay, now let's see. Okay. Now at the end I goofed, I put a well, I put a semicolon. We'll see. I probably got one of the quotes, but see, these strings are really tough to write. It's real easy to goof them up. Let's see. It told me that I had a missing semicolon, right? Missing semicolon, but I do have a semicolon at the end. Let's see. Go through quote plus this. Oh, see, I forgot the plus there. I forgot that plus. Okay. Now let's see. See, it's real error prone to write these long, complicated strings like this. Okay, there, right? So now step through here. Now I won't get those addresses in the output. Now I'll get my sense of what the output should look like. Okay. There's my two objects. Okay. So I'm now ready to print them. Okay. So call the print string, call the toString method. It's going to return a string. Then I'm going to see, there's the return string. Now I'm going to print the return string. Okay. Then see, I got a nice output. X is -5, Y equals -10, width equals 5, height equals 3. Okay. And then here's the other one. Okay. Now, in this output, I could have made it look like this: R4 equal. Okay. So this would make it, the output, even look a little bit better. This is R5. Oops. Oh, I meant that. That's R4 equals, close the quote, add on R4, and R5 equals, close the string, add on R5. So then that'll make the output look a little bit nicer. Step through just so we can see what the output looks like now. There. R4 is, okay, X equals this, Y equals that. And you can format this in any way you want, like this equal sign's a little bit confusing with that equal sign. This is saying that R4 is, and then here this is saying that X is, and some people put a parentheses around, like some people would write this with a grouping like this, like a left parentheses or a square bracket here with a, this is actually pretty common to put another plus, another quote, square bracket to close it off. Okay, that ends up making it look kind of nice. So that then Let me just let it, see, now you get R4 equals that, R5 equals that. So the brackets make it look like it's a unit. Okay, so that's a pretty common trick to put a square bracket at the beginning and end of an output like this. And then just say X is, Y is, width is, height is. Okay, now this is the correct way to let people to print out what's in your object. The toString method prints the whole object. Now I still, if I want to print out just a piece of the object, then I use the get height or get width. So if I want to print out the height of R4, let's see, the height of R4 is, and the width of R4, then I use the get method. I use the get method to look inside of the object. The toString prints the whole thing. Now, let me show you something that's not a good idea. Okay. Here's a method. You'll see this in some textbooks, and like one of the textbooks we're using actually points out that this is not a good idea to do this. Public void print. Okay. Public void print. Okay. I'll just say print. Okay. And I'll say system dot out dot print line. And then I'll just use the same string here. Okay. Okay. Okay, so I can print, I notice it's void. It doesn't return anything. It does the printing. Okay. And what it prints is the same thing as what toString does. This is considered not a good idea. Okay. In programming, we have a notion of something called, this is kind of a weird term. Misspelled it. Separation of concerns. Okay. Separation of concerns is the idea that every method should be concerned with one idea, and I shouldn't blur the concerns of two different methods. I should have each method have a single thing that it's interested in it. So uh, uh, there's even another name for this. Let's see, what is it? Oh. Single responsibility principle. Okay, so separation of concerns, single responsibility principle. The idea here is that a method should have just one duty. Okay, and every other, if you have two things that need to be done, then you should have two methods. You should separate the concerns. Every method should have just one responsibility. Okay, now this guy is doing two things. See, he's not separating concerns. He's not got single responsibility. Can anybody tell me what? See, now think, why am I saying he does two things? Think about it. Do you see what two things he's done? Anybody? Because this is important. Part of learning to program is to start thinking this way. You have to start thinking, what is the responsibility of a method? And is this method doing more than one thing? Have I separated the concerns? Have I given my method a single responsibility? This print method has two concerns or two responsibilities. Does anybody see what they are? Part of it is it overlaps with toString. Any ideas? What's the responsibility of toString? ToString has one responsibility, to convert the object to a string. See, It converts the object to a string. That's one responsibility. He's done two things. He's converted the object to a string, and he chose where to print it, where to send it to. So he did two things. He said, I'm going to build a string and I'm going to send it to the output. Notice that he's going to send it to the output with a ln at the end. Well, what if I didn't want the ln at the end? What if I wanted to put something after it? Should this thing put the ln there or not put the ln there? Well, I don't know, because I've given this thing too many responsibilities. I'm not even sure how it should really print it. Okay, so this is a bad method because it's actually got two responsibilities. This method does two things. It builds the string and it prints the string. That's one thing. That's one responsibility too many. This one has only one responsibility: build the string. Then up here, see, up here I can decide whether I want that to be an ln or like now, the two lines of output would come one after the other. This would print out, and then this one would print. Well, that's not the one I wanted. The one that used the toString was here. See, like now I could do that. Then this would print out, and this would print out on the line after it. Notice here I can decide what heading to put in front of this. Okay, down here, if I'm just going to print out this string, if I'm going to print out this string, I lose the chance to change what goes in front of this thing when it gets printed. Because I put too many responsibilities in this, they're muddled up, and it's not that versatile. It's way more versatile to separate concerns. So this one is only concerned with building a nice string. What you do with that string is not his concern. This method couldn't care less what you do with the string. It just is responsible for building a nice string. Up here, we can print the string with an ln at the end or print the string without the ln at the end. Okay, we could store the string in a file. We could send the string over the internet. We could do anything we wanted with the string that this guy is converted into. Okay, so it's now if you the result doesn't look any different. And a lot of beginning programmers think that this is really a good idea. Like, okay, let me just run it. You'll see that from the point of view of the final output, they look exactly alike. Okay. Well, notice that I was able to put this in front. I could do that here, but then I'd have to do something really hokey. Like what? Let me put this part in front of that. Now watch, it's going to be, look how bad the code is going to be. Okay. I would do the following. System.out.print without the ln, print the R4 equal, print that, then print R4. Now I can print the header for this one, R5 equal. But I need, look, see, now I need two lines of code to accomplish what this very simple line of code did. Because this method is really a bad idea. This print method is really a bad idea, and it's starting to show. It's getting awkward to use it. Okay, so let's look at the result. It really matters when you don't separate concerns. It really shows up. Codes get awkward when people don't obey these principles. Now, if you look at the output, see, it looks exactly the same. See? So a programmer can say, well, I got the same output you did, so what's wrong with my code? What's wrong with my code if I got the same output you got? And what's wrong is the person has to write very awkward code here. Instead of just saying something real elegant like this, system.out.println R4 equals R4, you have to do system.out.print R4 equals, then call this method on this object. Now, see, you need two lines of code. There's no way to combine those two lines of code because this part prints the preface, then this part prints the rest of the object. This is okay. So this method has taken on too much responsibility. Okay. So it can't be used in a versatile way, okay? As opposed to calling this, notice, and also I don't call toString. I get it for free. If you use the toString method, notice I just say R4 equals plus R4, and I don't actually, if I wrote dot toString here, I can write that. The compiler puts it there for me automatically. When the compiler sees you appending that variable to a string, the compiler adds the toString call for you. You don't need to put it there. So this is being toStringed and then being added onto that string. So I don't even have, see, so here I had to call print because I'm not getting any help from the language. So this is actually called, and this toString is called for me automatically. This is a really brilliant idea. The designers of Java, this was a really, it's a simple idea, but it actually works out beautifully. It makes it real nicely to write code to make use of this automatically called toString method. The toString method has a single responsibility of stringifying your object, nothing else. It shouldn't print it. It's wrong to print that string. This is wrong. ToString only does it, only makes it a string. You get to decide how you're going to use that string. And the compiler calls the toString method for you automatically when it sees you printing the string, when it sees you printing the object. Okay? Right? So, we really take seriously separate. This is a good example of, you can think of this as an example of both of these ideas. These ideas are very closely related: separation of concerns and single responsibility principle. They both more or less say, make things in your code just do one thing. Like in the case of here, the rectangle class should only do rectangle things. Okay. So separation of concerns was that a rectangle should only do things that are important to a rectangle. Yeah, it's hard to imagine what else a rectangle class could do, but when you're designing classes, the single responsibility principle says that, well, classes should only be concerned with one concern. In this case, rectangles should represent rectangles. Okay. That it's not hard. The case of rectangles, it's hard to imagine any overlap with other things, but a rectangle class should only be concerned with one thing, rectangles. And same way, it should only have one responsibility. It should only represent rectangles. Okay, that's a little bit more easy to explain in this here. The toString method definitely has only one responsibility: convert the object to a string. Okay, so it separates the concern. So here, two concerns were blurred together: how to convert the object to a string and where to send that string to. Okay, so two concerns got blurred together: how to convert the object to a string, then where to send that string to. Okay, in the case of here, I've separated those concerns. The toString method takes care of making it a string, and then here I decide how to send it out. I decide whether I want to print it, whether to save it in this in a file. I'm deciding what to do with the string here, whether to put a header in front of it. See, I'm deciding the other part right there. So this guy only does one thing for me. Real important idea. ToString's a very good example of introducing this idea of why you want to do ToString and not this. Don't have don't have objects print themselves. Okay. Don't ever, you should never actually have an object print itself. There should never be in an object a method like this that prints the object. It's always, I'd say, a wrong thing to do. Okay. Use the toString method. Convert the object to a string, then decide somewhere else what to do with the string. Okay. All right. Now, let's see, what else can we add to this object? Okay. Now, here's another thing we would want to do. Once I have two objects, it might be useful to know if they're equal to each other or not. I might want to know if is R4 and R5 the same object. I would want to be able to do something like this: is R4 equal to R5? Okay. Now that's a Boolean. Actually, it's equals. It's spelled equals. In Java, you spell this equals. So I'm going to say Boolean B equals, okay. Now, right now, let me make them equal. Let's see. So let me make this 2, 5, 3, and I'm going to, I'll comment out that for now. Oh, let's see. Yeah, I'll leave those. I'll comment them out so that so that way I get 1, 2, 5, 3, 1, 2, 5, 3. So I'm creating two objects that are equal. Okay. Okay. Let me step through building them. Okay. There's two objects, 1, 2, 5, 3, 1, 2, 5, 3. Okay. False. They're not equal. Well, that's because we haven't told the rectangle how to compare. We have, like, Java doesn't really know that what a rectangle is. So Java doesn't know how to tell if they're equal or not. In fact, what happened here was, by default, just like the toString method by default printed out the object's addresses, the equals method by default compares their addresses. So R4 and R5 have different addresses, so they end up being false, not equal. Now watch this. I'm going to create a rectangle R6, but instead of making it a real rectangle, I'm just going to make it another name for R4. Then I'm going to ask Boolean B2. I'm going to ask, is R4 dot equal R6? Okay, so make this Boolean one. So I'll ask, is R4 equal to R5? Now, R6 is just another name for R4. So R6 and R4 point to the same thing. Okay. So essentially, R4 and R6 have the same address. So this will end up being true, but this one's going to be false, even though R4 and R5 hold the exact same numbers. Because what equals does, oh, what did I do wrong here? Oh, I forgot the S again. Equals. What the equals method, oh, well, now what I do? Oh, I used, I had B1 and B2 down here. So let me change that to a B3 and a B4. Okay. Okay. So step through making everything. Okay. B1 equal B4 is false, even though they got the exact same things in them. Now, R6 is just another arrow to R4. So it tells us that they're true. That's true. But that's not useful. I mean, it shouldn't be true. Our rectangles shouldn't be equal only when they point to the same object. This object and that object should be considered equal because they hold the same data in them. Okay, so I want equality to tell me the two objects hold the same data. By default, equality tells me that they're the same address. Just like just like this toString, by default, when I didn't define my own toString, I got one for free, but it just printed out the address. If I don't write my own equals method, I get one for free, but it compares addresses. So down here, I need to write my own equals method. So I'm going to write public Boolean equals. I'm going to write my own equals method. That now I'm essentially replacing the default one with my own one, and I want to compare this object to that object. So equals will take in another object that almost everybody calls that, and I'm going to compare this and that. Okay, so what I'm going to say is return this dot x equal that dot x, and this dot y equal that y. And I just do this for all the variables. So I just write out this lot. Now notice it's kind of like the toString. It's going to be kind of like a long thing. I could make it a little bit easier to read by breaking this one up like here. So this x equals that x, this y equals that y, this width equal that width. Now the thises I could drop from my code, but not the that's. Okay, I could delete that this because the only x is that x there. So this x is that x. Of course, I can't remove that because then this is going to be true because that x is also that x up here. So I'm just comparing x to itself. So I have to have the that there, okay? But it's up to me whether I want to write the this. I'll just go ahead and leave it there because it makes it more obvious that I'm comparing this and that, okay? This is one place where it makes it nice to put them in there. So this, I'm comparing this and that height, this and that width, this, okay, and this height equal that. Okay. Now, here's a problem. Width is private in that object. So you might think I need to do that dot get width, but I don't need that. Java was kind of clever. If you have a rectangle parameter in a rectangle method, you can ignore the privates here. So when I'm inside the rectangle class and I'm writing a rectangle method, if I have a rectangle parameter that's another rectangle, I can look inside of it. I don't have to say that dot get width. Now, there are people out there who think you should write it this way. There are actually books that'll tell you that, well, if this thing is private and you have this get height and get width, you should use them here too. So you should say this dot width equals that dot get width. I don't think it's really necessary to use the get method, and Java doesn't force you to. So Java doesn't require that you do this. Now there are programmers out there and companies out there that say, well, if a field is private and there's a get method for it, then everybody should use the get method, even when you don't have to, like here. So even here in my equals method, I don't have to use get width. Okay, so what I'll do is I won't use get width, but I'll use get height. Just show you that I can do it either way. I won't use the get width, but I will use the get height. This is good enough. I mean, as far as Java is concerned, this is good enough. Some companies and some books and some programmers say that if it's something is private and there's a get method for it, you should always use the get method. Okay. Now the key is that this will now compare two rectangles. Instead of comparing them by address, which is what Java did by default, instead of comparing them by address here, now we're going to find out that R4 really is equal to R5. Okay, so let me go ahead and run it. The equals method and the toString method are things that you have to define every time you define a class. So every time you define some class, you should define toString and equals. You don't have to because you get free ones, but the free ones don't work very well. The free equals compares addresses, and the free toString prints addresses. So neither one is very useful. Okay. Now, see, my Booleans now, B1 is true and B2 is true. If I go back to the beginning and step through, yeah, now when I ask if the two methods are, if the two objects are equal, it calls my equals method, not the default one. Okay, where are we? Okay, build that other object. Okay, now, let's go back. Okay, here's where I did comparing R4 with R5. Okay, now here's something funny. The visualizer did not jump into my equals method. You notice that it didn't jump into my equals method. It skipped over it. This is a quirk in the visualizer. Remember, there was a built-in equals a little while ago, and so it was built in, so the visualizer doesn't show it. We replaced the built-in one with ours, but the visualizer still treats it like it was a built-in equals method, and it doesn't show us this code executing. And I think that it's a quirk on the part of the visualizer. Okay, so, or did it? No, I'm sorry, it did jump in there. Let's see, where are we? I'm not, let's see. I've lost track of where we are in the code. It gets confusing when this thing bounces around on you a lot. I thought it jumped over that. So let's see, where are we now? We are in get height on line 18. We came from the equals method we did call equals method. So let me back up a couple steps. Okay, now we're at line 13. I'm sorry. So here is where it is going to jump into our equals method. Before that was their equals method, the default one, and it didn't jump into it. Now it is our equals method, and it will jump into it. Okay. So now we're going to test. Now we have to jump into get height because we used it down here. So now we're going to go down here and jump into get height. We don't have to. Notice that this thing didn't jump into anything because it just accesses the variable directly. This called a method, so we had to jump into that method. So now we can return, now we know that we can return true. This was true, that was true, that was true, that was true. Okay, so the equals method returns true now. Okay, so it compared that x to that x, that y to that y, this x, that width to that width, that height to that height. Okay, now it'll still be true that this other one is going to be true. Okay, notice that R6 and R4 point to the same object, but this is still going to go into the equals method, and now I'm inside equals method, and this and that point to the same object. And it's still going to go through all the steps of checking that this x is equal to that x, this y is equal to that y. It's a little bit, now this can be, I can avoid doing all this. Watch, there's a little trick. If this equal that, return true. Okay. Otherwise, return this. Okay. So if this equals that, return true. That skips testing all the fields. This is asking, is this arrow equal to that arrow? If the arrows are equal, then they're pointing to the same object. So that skips having to do all this in the special case, like what we had here, where this and that are the same arrow. This and that are the same arrow. So let's watch that this will shorten the equals method in the case where this and that are the same. So let me step through a bunch of building. We're actually doing fairly sophisticated programming at this point. This is fairly sophisticated object-oriented programming where you have to really think about I want to back up a little bit. Okay, I'm calling equals. Now, in this case, this is here and that's here. So that's not the trivial case. So I don't have this and that equal. So I skip over that. Okay, so that's not true. So then I have to compare all the fields. Okay, and I got true because x was equal to x, y was equal to y. Okay, now I create this alias for R4. Remember, when you have two arrows pointing to the same object, we call that an alias. So now I'm going to ask, is R4 equal to R6? Well, that's trivially true because R4 and R6 are aliases for the same object. Now, this, see, this equals that. I found out, well, this is equal to that. I don't need to go look at this x and then look at that x. See, I don't need to go look at this x compared to that x. I don't need to do all this. I can just stop. I know that this is equal to that. So this is a little trick that people use. This is almost always the first line of an equals method. If this equals that, return true. Okay, and that stops you from having to go through all the work of checking all the fields in the object. Okay. Okay, so I get true here. Okay, so we're doing pretty sophisticated programming at this point. When we think about two strings, equals, single responsibility principle, we're actually introducing quite a few ideas, the ideas that you'll keep seeing over and over again when you're programming, especially, this is something, the separation of concerns and single responsibility principle are something that gets hammered at programmers over and over and over again. Because one of the problems that happens when people write software is they break those two rules. And that's usually the source of bad software design and messy software. This is considered these two ideas are really super important. Separating concern, making sure that everything has one responsibility really helps improve the quality of programs. Okay. All right. Now let's see, what else can we, we've we say we overridden the default equals and the default toString. So our class knows how to tell you when the two rectangles are equal, and our class knows how to convert a rectangle into a string. Okay, so that's important. That's something that every class should do. Define its own equals, not accept the default one, and define its own toString, not accept the default one. Okay. Now let's see. Let's do another example. We made the object. Oh, now notice that we made width and height private. What if I want to change the size of the rectangle? Well, I can't change width and height because they're private. So if I want to, like these are public, so I actually didn't even need these move methods. Notice that if I wanted to move a rectangle, I could just reach in and change its x value and move it. But it's kind of nice to have these move methods because it makes it easier for people to write and read code. So I don't have to have these two methods because I can always reach into the object and change the x and y. But I can't reach into the object and change the width and height. So I need something, if I want rectangles to grow and shrink, I really need methods for that. So let's create a grow method. Okay, so public void, a method that's going to make a rectangle grow, and I'll say grow to. And I'm going to write two grow methods. One that's public grow to, and one that's just like we had to move. It's going to be public void grow by. Okay. What do I mean? Grow to will just give you new dimensions for width and height. So this would be double new width, double new height. Okay. So just grow to those. So that will then just say this dot height equals new height, and this dot width. Now I don't really need the thises here, but I'm just kind of putting them in there to remind you that I'm changing what's in the object I'm calling it. This new width. Okay. Now some programmers would just write this as width, just like in the constructor. Okay, then this dot height equals height, and this dot width equals width. And you can write this any way you want. You can use the same name here as what the field is, but then you have to say this height equals height, this width equals width. Or you could give these guys different names, like you just use W and H here. Then you would just say height equals H, width equals W, and then you don't need the this. Okay, so all kinds of programmers have different styles here. Like this, as far as I'm concerned, that's perfectly legitimate. Height equals H, width equals W. Yeah, these are simple variables, width and height. Some people like to write, some people like to write new width, new height. Okay. Some people like to write width and height because that's what the fields are. Width, height. Some people think that's a good idea because that's what they are. But then you have to put this height equals. Now, there's no real right and wrong. This is something that all these different ways of writing this grow to are just not important differences. So you could just whatever way you like to do. Okay, so that's grow to that. Now, grow by, I'll use deltas. I want to grow the width by delta width. That could be a positive or negative number. So that could make and I want to grow double delta height. Okay, delta height starting to get to be too long to write, so I'm going to make it delta H and delta W. Okay, those are pretty easy to read, delta H and delta W. Okay, so then down here, then this, I'll just write width. That's this width equals width plus delta width. Okay, and height equals height plus delta height. Okay, so now I've got two ways of growing the rectangle. I can grow two specific dimensions. I can grow two specific dimensions, and I can grow by an amount. Make the rectangle 1 unit longer and 1 unit taller. Okay, and actually there's even a third one. Watch this. I could say the following. And actually in the real world, if I was writing this as real code, I would probably draw all three of these. I'm going to do another grow by. Okay, but I'm going to make this grow by just one number. It's a double that's a scale. Grow by scale. Now, that would be like 2.0. That would mean double the rectangle. Or 3.0 would be triple the rectangle. 0.5 would mean halve the rectangle. So the way I use this would be is width equals width times the scale. And in the real world, that's exactly what you'll see in graphics programs. You'll see three ways of growing. If you have a rectangle, you could want to say, I want to grow to exactly these dimensions. I want whatever its current size is to be increased by, say, 1 and 2, or I want to grow it by a scaling factor. I want it to be doubled or tripled or halved. Okay, so there, when we write code like this, notice we write a lot. No, these are all kind of redundant. If you got one way to grow, you don't need other ways to grow, but you're actually trying to code for the convenience of people who use your software. So people who are writing the code, sometimes they want to think this way, sometimes they want to think this way. Sometimes they want to say, oh, my rectangle needs to be these dimensions. No matter what size it is now, it needs to go to that size, that size. Other times you're thinking, well, I don't, whatever the size of my rectangle is, I want it to grow by 1 unit in the width and the height. So I want to grow by. So I don't want to really, I don't care what size it is. I just know how much I want to grow by. And other times you want to grow by a scale. I want my rectangle to be 20% larger than what it is now. So I want to grow by a scale factor. So you give people all three of these. Any one of them would be enough, but it's convenient as you, the programmer, to give them all three of them. Okay, so there's three different ways to grow my rectangle. Okay, grow to, grow by, and notice that these have the same name, but they have different numbers of parameters. So when I call grow by with 2 parameters, they're the amount to add on to the width and height. When I call grow by with 1 parameter, it's a scale factor. Okay, we call this overloading the function. There's 2 functions with the same name, but they have different numbers of parameters, so I can let them do different things. So when grow by has 2 parameters, it's the amount to add to each dimension. When grow by has just 1 parameter, it's my scaling factor, and I use that scaling factor on both dimensions. Okay. Now, let's make sure I didn't make any silly compiler errors. Oh, see what I do wrong. Oh, I forgot to write void in front here. Now, these are void methods because they change what's in the object. They don't return anything. They just change what's inside the object. So they're what people call mutating methods. They don't, oh, now what I do? I misspelled height. Okay. See if I got any other mistakes. Yep. What did I do? Misspell width. Yep. Okay. Okay. Now I could, I haven't done anything with those. I can go up here if I want in my test program. I could play with those. I could use them to change this. But I have a problem. Did anybody notice there's something wrong here? Anybody notice? Anybody notice that I've forgotten about something? Why did I make width and height private to begin with? Remember, I made them private because I don't want people sneaking negative numbers in for width and height. Width and height should never be negative. So I made these private to avoid ever getting a negative width and height. But now I'm letting somebody change them, and I didn't check. Okay, so what I'll do is I'll do this. If the result of this change was, if this dot width is less than or equal to 0, or this dot height. Notice I'm doing this after I made the change. So I'm going ahead and whatever they gave me, I'll go ahead and make the change to height and width. And then I'll say, if I end up with negative numbers, I'll throw new error. Same error that I was throwing in the case of the constructor. Okay. Okay. So if if after making those changes, the width and the height are negative, I'll throw a new error. But I want that in all three of these. Well, I need it in this one, need it in this one. Okay. Now, here, how can I get these guys to be negative? Here, I'll change the code a little bit. Here, the error would be if the scale is negative. If the scale is a negative number, then these are going to turn out to be negative. Okay, so I'll test. Notice here I'll test the input. Here I'm testing the result, the output. I'm making sure that after I make those changes, width and height are not negative. I could have checked these deltas, but that would be kind of tricky because then I have to compare the deltas would depend on what the width was. Like a delta of -1 is fine if your rectangle is larger than 1 wide. Yeah, but if the rectangle is smaller than 1 unit wide, a delta of -1 is not good. So it's probably easier just to go and make the changes, then make sure the numbers aren't negative. Okay, so I'll make the change, then make sure the numbers didn't become negative. Same here. Okay, here I know that the only way that can go wrong is if the scale is negative. That would be the only way I can, if these are always positive, the only way to make the result negative is if the scale is negative. Okay, so now I'm protecting my data. See, I want to make sure I always protect my data. I got to make sure to not let my data, let somebody sneak in illegal data. So once you've made something private like this, real important idea in object-oriented programming is if you make it something private because there's illegal values for it, you have to make sure you keep checking that. So every time you have some method that might change those fields, you got to make sure that they're still valid. Okay, so I have to make sure that I still have valid fields, Now notice that I'm doing that checking here, here, and here. And somebody might say, but you're testing the same thing over and over again in different places in your program. Here I'm making sure that somebody doesn't sneak in negative numbers. Here I'm making sure that the result doesn't end up being negative. And here I'm checking. But I've got now 4 places where I'm checking my data on width and height. And somebody might say, you probably should come up with having the check and be only in one place. So for example, I could put a method in here that just checks whether width and height are positive. And then I could call that method, okay? And so, yeah, right now I'm just gonna leave it the way it is, but somebody could complain that I'm duplicating code. I'm testing here whether I have negative values. And I'm testing here if I have negative values. And I'm testing here for negative values. And I'm testing here for negative values. That's 4 places where I'm kind of doing the same thing. And somebody might say, you should figure out a way to make that all be done in one place. But right now, this would be good enough for us. Right now, the key idea is that I need to protect the data. The width and height should never be negative. I've made the width and height private. But now, since I've taken on the responsibility of making them private and saying that they should never be negative, I have to keep protecting them. Protect them in the constructor, and any method that could modify them, I have to check. Okay? X and Y, I don't care about. Remember, X and Y I don't really, here, these are just convenient methods. There's no illegitimate value for X and Y. So I give people these methods for convenience, but I could let them poke whatever value they want into X and Y. Here, I have to give people these if I want them to be able to grow and shrink the rectangle, because the width and height are private, and then I have to protect the values. Okay. All right, so we've run out of time, but notice that we're really introducing a lot of ideas here. We're talking about designing objects. We're talking about what do you put inside of an object to make it convenient to use. What do you do with an object to make it realistic? Like in this case, rectangles shouldn't have negative dimensions. So I'm making the rectangle realistic by making those private. So it's something that's actually making the class act more like you would think a real rectangle would. It shouldn't have negative dimensions. Okay, so we run out of time. So make sure you look at the homework assignment. So on next week, on Tuesday, if you have questions about the homework assignment, we can go over that. And also, remember, there's now review problems for the upcoming test. There's some nice questions in there about object-oriented programming. So again, on next week, if you have questions about those review problems, we can look at those also. Okay. And also, if you have questions about the previous exams, like if there's anything, because it's been a while, some of the stuff we haven't talked about for a while. So if you've got questions about, anything about the upcoming exam, the upcoming final, any question about that or the homework assignment, and otherwise next week we'll continue to talk more about writing classes. We're going to talk a little bit more about the object-oriented programming in classes. There's still a few more things to talk about, but we'll also, if there's any questions about this stuff, we can go over that too. Okay. So anybody, any last second question? Okay, so have a nice weekend. If you have questions, I have office hours today, so you can come to office hours or send me an email. So if you have questions, please send them. Okay, have a nice weekend. Bye.